exascale, cloud computing, IIoT, blockchain, parallel compilers, and so forth. Dear Shajulin sir, we know that you doesn't need a formal invite in any of the sessions organized in IIIT Kottayam. Over to you, sir. The stage is yours.
Thank you, Mr. Sabin, as well as Dr. Victor sir. Definitely, it's an aspiring thing for me to give this talk to the faculties who are aspiring to take the work on IoT cloud. Definitely, this session, we will be discussing a little bit more about IoT than how cloud has influenced this particular area. As the introduction was given, yes, I'm working here in IIIT Kottayam, and some of the activities like some projects which I have already taken. Of course, it was discussed already earlier. And then, yeah, let me quickly start the session. So basically, initially I will start with IoT, the subdomains of IoT. Then I will cover how this cloud aspects are influencing IoT trend. And also the analysis that could be carried out for such IoT-enabled cloud systems. Yeah, as it's a more specialized topic. Still, I would like to give some more brief about what this Internet of Things mean. Basically, it's an extension of Internet. Okay, so Internet, earlier it was just given to compute machines, servers, then even mobile phones. Now it is extended in the sense it is, we try to provide Internet even to things. That's why it is Internet of Things, right? So like the things could be like table, chair, fan, light, right? Any kind of such kind of things should get Internet, right? So it means we have to talk to those devices, right? So it is therefore expected that in the future, this particular Internet could reach trillions of sensors or digitized objects for connections, and billions of personal devices. Like we all know, like individually we have several personal devices, phones, iPads, then laptops. In addition, nowadays, a lot of wearable devices like wristwatches and so on are becoming more common these days. So future Internet is something where you get Internet to these simple devices, things, so that the connection is more strong, in the sense we could get the communication much easier here, right? So entrepreneurs, business people, technical aspirants, as well as many working professionals in this domain have already started to rethink how we can apply IoT and cloud together to get a lot of benefits or a lot of support, right? In fact, although we told that it's a future Internet, it's becoming more popular because you are also aware. It's because we get very smart society, right? This particular example I would like to highlight here, like in the future, a lot of robots will be functioning, right? The way how we communicate with the society is, it could change in the future, because robots can lead sometimes, or like you like some people, you dislike some people. So the same characters can be modeled in the form of robots, and the Internet of Things based devices could connect you for better future. right? So similarly, knowledge-driven society, like imagine that you have farms, or you have a lot of centers where you want to be more productive. Like for example, um, I have a target of say completing something within a particular period of time. To be more productive, it is always better to have some knowledge systems, like Internet of Things assisted solutions, which can remind us to keep us more productive. For example, if my diary on the table is talking to me saying that now I have to start like this, or if my mobile phone is connected to those devices like pens, saying that I have to write something on the paper, these are the things. So things are communicating, and all the things that are around you are connected, right? To keep the society more knowledgeable, to keep people more knowledgeable. So this setup will definitely create a lot of productivity in the future, right? Similarly, cognition-enabled machines, right, or expert systems, a lot of intelligence you can infer from this Internet of Things, right? Devices in home, offices, motels, coffee houses, airport, gyms, hospital, all things are going to get connected, right, through this Internet of Things. So imagine that there are several solutions that you can think of in airport. Like for example, you just wander into or walk through the airport, and if the sensors or the cameras are able to track, right, how happy are you during the travel, right? Some people find difficult during traveling, and this emotions could be captured, right? And the analysis could be done based on that, right? So Internet of Things, as I have told, it's an extension of Internet, which is going to create a lot of benefits. And in this lecture for another 1.5 hours, maybe we will be rethinking how this things could be connected things could provide easiness for the society with the inclusion of system like clouds. Okay, so that's why just I'm giving like a base from, I'm starting from the base with IoT, and then we move on to the topics. Of course, I'm just quickly going through the definition. Like Internet of Things is, as I pointed out, it's extension of Internet, right? To devices, not just mobile phones and computers, it's also to things, so that the things are talking and we get knowledge out of that. Okay, let's see how this IoT is, really influenceable to the society or the people around, right? You can notice very clearly from the graph that the publications keep rising, right? So 2020, right, you could see around 1,800 publications with the keyword of IoT. And this is, mid of 2021 could be, right? But if we check 2021, it's again going to rise typically in the same form, right? Similarly, if you see the patenting status of IoT, it's still, you can notice that many patents are happening through this domain. Of course, you can imagine, like if it is pure software, definitely patenting is a tough thing. But when you merge the systems with some hardware, patenting is much easier, right? So you can see how quick the patenting is also moving on. So this all shows that the trends, like IoT is definitely a worthwhile investing time for you to explore this particular domain. Similarly, the investors see, here you can see like the Internet of Things market, which was predicted till 2030. You can see how much, amount of or the percentage of money is flowing towards this IoT field, right? 1.5 trillion revenue is expected in 2030. So I believe that you all have this idea of like entrepreneurship, startups, and so on. There are a number of solutions or problems that you can find in the society. Like, for example, a person traveling in the bus, reaching a particular location, he doesn't know when the auto rickshaw will be available or when the cab will be available. He could book something, but can he priorly do that, right? So whether your devices could automatically do that, right? So, for example, I am traveling from Chennai to say my village nearer to Trivandrum. So I got the bus to reach Trivandrum, but my mobile phone should automatically speak to the concerned auto driver maybe, and it has to say that I will be reaching around, say, this particular time. You should reach a particular bus station, right? So these are all problems which we don't pay attention much, right? So if we could clearly or keenly watch these problems, there are ways how we can solve them, right? IoT plays the major role there. The Internet of Things could be thought about several problems or several societal problems could be addressed to this. And at our IoT Cloud Research Lab, we normally try to find a lot of solutions based on this. So in which domains IoT really fits very well? If you see, smart cities, connected industry, connected building, connected car, smart energy, connected health, smart supply chain, smart agriculture, smart retail, and many, many domains, right? Here I have just shown you the trend of IoT projects that are coming under these fields. A smart city is different from cities, right? The major difference compared to cities are in smart cities, you have not only the sufficient infrastructure, you also have the the revenue model, right? So the citizens who live in smart cities, definitely they have to get some reminders in their mobile phones, or the connected things should talk such that they get more profit, more revenue, in addition to the comfort that they get in the smart cities. Connected industries, of course, the industries currently we know, it could be like a major plant, with a lot of units, industrial units, and these industrial units could connect each other in the form of sensors and actuators, so that the sensors could keep the process of the industries more beneficial in the to keep the system more productive also. So like this, you can see like connected building is there, connected cars, connected health, right? Smart supply chain, you can notice like 23% of growth you can see in smart city, and so on. So if someone really wants to take the research domain in various fields, you can see these trends that IoT plays the major role in all these domains. Yeah, this figure shows how many patents have been filed by different companies in the past. Now, having understood what Internet of Things is doing and what are the real future of Internet of Things, I would like to highlight some of the platforms that are available for IoT. So the right side, you can see the graph which shows which platforms are much commonly utilized, right? I would like to make you notice that, top three, like Amazon Azure, Google Cloud IoT, as well as Amazon AWS IoT with Greengrass. These three have some similarity with clouds, right? Many of you are aware, like Microsoft Azure means it's cloud from Microsoft. Google Cloud, Google is responsible. Amazon, they have already infrastructure providers, right? They are the infrastructure providers. They have moved to, not moved, but they additionally have support for this IoT. So if you see the most of the platforms that are available, from the leading platforms that are currently seen over here, you can observe that cloud providers have shown much interest to IoT, right? So around 29% of developers favor Microsoft IoT suite, right? So typically, cloud researchers, they started their work with the support of IoT. The reason is because the things could communicate through the cloud, and a lot of analytics and intelligence could be done with the help of cloud. So we have seen that IoT is having definitely a lot of progressive trends in the future. But now when you merge this with cloud through some infrastructure services, there is a even major possibility of developments. Let me also highlight how this could be of more interest to the education sector, like foreign language translation. People go to some other countries where the languages are different, like South Indian people go to North India, and North Indian people come to South India. The languages are different. Of course, English could be the common language in India. But if you go to countries, like China, Germany, the language, you have to understand that particular language. But this language translation could be done with the help of things like, for example, the cameras could capture, translate it, and it can tell you how it is represented, right? Or someone speaks to you in some other language, it could translate and give it to you in your native language, right? So education system hereafter could change, right? Someone from here, from India, could talk or view the lecture in their own language without any barriers, but the translator is going to translate and address international students maybe at different locations, right? So such kind of things are possible using IoT cloud. Connected smart classrooms, smart experiments are possible. Like, for example, now, at least with the help of Corona, we are able to sit online somewhere and listen as well as attend the classes, right? So, but it was a concept that smart classrooms should bring something similar. Prior to before thinking of before the policies of such Corona. So people were like thinking of having virtual meetings with cameras and so on. So they stay somewhere and they attend the meetings, and they stay somewhere in different locations too, and they could attend their customers. So this kind of smart classrooms are possible with the help of these devices. For example, are you really listening to the talk? Are you not listening to the talk? Still, there are no solutions, right? at least we are making it online, and we are giving, we are discussing or sharing our ideas each other. But there are no a real good solution that shows, out of 110 participants, maybe this particular participant is not really attentive. This particular participant is very keen in listening to a particular topic. So that kind of smart classroom, smart experiments are not fully available. This means we have a lot of room for developments, right? Similarly, collaborative learning in classrooms. If a project is there, and if it has to be taken in a collaborative manner with a group of 20, 35 students, that could be possible through this IoT setup, right? Also support to disabled students who doesn't listen, who doesn't hear, right? All these educational sector people are currently working on. Institute, organizational security, classroom monitoring, using video as a sensor technology, right? Attendance monitoring, student physical as well as mental health analysis, like some students sit continually in front of the computers, and there can be some warning systems that remind people to say, get up, have some refreshment, come back. So it's a part of mental health as well as physical health to keep them engaged, but still more productive with the help of these devices. Learning from home. So as I told earlier, someone speaks in one language, and this will be addressed in their native languages. Of course, it's not fully complete solutions, but there are rooms for developments in the future, right? Yeah, there are several protocols and so on. Someone has written, I think several devices are getting connected every day to internet, how the co-op authenticate all these devices. Yeah, so there are protocols like constrained application protocols, but there are secure constrained application protocols too, that can authenticate the devices. Of course, I will throw a very little light on the security part of devices, but more towards cloud part, right? So subdomains. So we have seen what IoT is, what IoT cloud can do, the trend relating to that. Now let us see the different IoT domains like industrial IoT, consumer IoT, social IoT, semantic IoT, and productization IoT are the five major subdivisions. I will quickly go through these subdivisions, and then we will talk about the clouds in that respect. Right. So industrial IoT, from the name, we can understand that it is connecting industries with the help of sensor devices. So smart products are designed, data-driven as well as event-driven automation processes are possible through this industrial IoT. Right. Car manufacturing, 3D printing, energy industry, healthcare, all these industries are potential domains where this industrial IoT plays a major role. Like for example, car manufacturing, you could do predictive maintenance, like a tire is of your vehicle is having, you may not know whether it is, it has to be repaired now, right? But if a sensor is attached to the tire, it can talk to the concerned workshop. The workshop could communicate to concerned tire manufacturers, and the tire manufacturers can start producing the relevant tires of the same model, and it can communicate to the owner saying that now you have to reach the workshop so that everything is set up for him. right? So it keeps you more productive, and you can save a lot of money out of that. So anything related to industry or utilization of sensors relating to industry is typically called as industrial IoT, right? Industry 4.0 is typically a name that they give for industrial IoT, right? So Industry 4.0 is based on Germany, and the same term is used as industrial internet in the US, right? It's typically the revolution that models in industrial processes, right? Fourth industrial revolution. So the previous revolutions are like, first one in 18th century when water and steam was introduced. The second one in 19th century when electrical engines of power revolution things happened. So for example, belt conveyors. The third one is like electronics and IoT. And then now you can see the fourth revolution, which is the utilization of Internet of Things. Of course, people are also talking about Industry 5.0, which is even still further away from what we want to discuss, right? So the reason why they brought it is because of the industrial revolutions required for that, right? As I have told, you can use, typically they use these applications for like spare parts replacements and predictive maintenance and so on. For customers, it's really useful because you get customized solutions. For industries, it's also useful because you get the mass requirement for developments. Okay, so in the future, this product life cycle can even become much similar. Like for example, people can design their own car and they can start the process of printing cars also in the future. Right, so there are several technologies that are associated with this, like big data, autonomous robots, simulation, horizontal and vertical integrations, Internet of Things, all these technologies, right? So it's a mixture of many technologies put together, but in the industrial arena. So therefore, it's called the subdomain as industrial IoT. The second subdomain of IoT is consumer IoT, which refers to consumers, right? Any devices that are assisting a consumer, like personal devices, for keeping them productive is called as consumer IoT. It's a subdomain. Devices such as wearables, gadgets, fashion items, portables, implantables, handhelds, then consoles, and so on, right? So even voice assistants, there are devices for voice assistants. Like you speak in one language, it will reply to you in another language, of course, or in the same language, but keep you more entertaining, right? Because many of you also, we all agree that we find comfortable with some of the characters, right? Definitely the family members you speak, you feel comfortable, you feel happy. But when you want to speak to a colleague or someone from the workspace or to your boss, right? So it is not much entertaining in that sense, right? So if you want to have a very peculiar mood, you may need some sort of devices that can talk to you, that can communicate with you, so that you, when your energy level is really high, you will be more productive, right? So in earlier days, people stay with some friends, right? The friends will give a lot of energy, and with that energy, they become more productive. But it is not a real case that we can get such kind of friends all the time staying with us, right? So it is very likely that we should have devices like this which can communicate with you, such devices which can give a lot of support. Similarly, creating safer homes, challenges relating to like wearables or heterogeneity, right? As well as security. Security is a major domain, which I think it's important, but I will not cover that security aspects much here. But no devices, heterogeneous devices, which produce the devices from different different products, different manufacturers. Like for example, if you're using Arduino microcontroller, or if you use expressive devices or some other devices, ARM-based devices, whatever device you use, right? So there are a mixture of heterogeneous devices. How do you connect them and how do you authenticate them? So these are all some different research challenges that you can find in these fields, right? Some other examples with wearables in healthcare sector is prevention of diseases as well as maintenance of health. Like for example, elderly people fall very frequently above 85 or typically above 85 they fall. So this fall identification as well as prevention is one of the important criteria. Like you can have some airbags fitted to your body. So once you tilt to a certain angle, immediately the airbag will open, and so you can fall down, but no fracture, right? Which is very useful for elderly people. It's a part of wearable. Then mental status monitoring, like always there is a stress that we want to organize FTP, and our coordinators will have that stress. Right? People who attend will have some other form of stress. People working in some domain, they have some other kind of stress. So this stress monitoring is also one of the important thing. Typically, some wearables, wristwatches are also available in the market to check that and provide it through Internet of Things. You can also suggest some medical decisions, right? And diabetic people, they normally get different levels of glucose, like suddenly it increases to 180, 360 sometimes. Suddenly it drops down to 40, right? If it's dropping down to 40, 20, it's unnoticeable, and many homes where elderly people are staying alone, there are no possibility for them to rescue. We could not do anything. So Internet of Things based solutions could definitely help in those categories too, right? For continuous monitoring of these chronic diseases, diabetic patients, cancer patients, stroke patients, and so on. So immediately the warnings will be given to the connected hospitals, and the hospitals authorities could do some countermeasures immediately, right? Weight control applications are also becoming popular. Physical activity monitoring, right? Because nowadays everyone sit in front of the computers continually. Almost all students are doing this continually. It not only affects the eyes, it also affects the physical health, right? So there are some Internet of Things solution that reminds the person, saying that you should now start to walk, you should do some physical things, physical exercises, so your body mass index becomes normal, right? It cannot be so comfortable in cold countries, even like in Germany also, right? So then you should have some textiles, right? People are developing such kind of wearables, and these textiles can warm up, keep your body to certain degree centigrade, right? So typically all are automated. That is the important feature here in IoT enabled devices, wearable devices. So skin attachable devices are people are developing these kind of devices much commonly these days. And smartphones or your mobile phones typically act as edge devices. I will talk about this edge in the coming slides. So next comes social IoT. So out of subdomains, the next category is social IoT. Social IoT is about connecting some information like social information, sensing information from the social medias like Facebook, Google plus LinkedIn, and so on. So you have several followers typically. At least if you think about some politicians, they have several followers, it is always a known truth that you cannot satisfy a statement with all the people, all the followers, right? You cannot do that. So sometimes you speak something which will create a bad impact to some sector of group of people, right? Which you will not notice, but social IoT devices or that kind of applications can notice that. Say, I give a talk, and or I make a Twitter message, right? And it reached, say, 1 lakh group of people. Because of this tweet, a sector of my own followers became enemies, right? So if I could get some information relating to this, right? So immediately I can make some solution for that, right? So that kind of subdivision is about social IoT, right? Yeah, there is a question how the connectivity is ensured and maintained at the as the IoT devices are huge in number that get connected every day. So it typically talks about the connectivity. So there are several connectivity protocols, right? Say, for example, if you have 20 devices, if you're using Wi-Fi kind of sensor devices, you can easily connect, right? But if you think that you need to use Bluetooth, still you can manage, right? But if you think that you need some wired connections, it is limited to the amount of pins that are there. But it naturally depends on how many devices that are capable for connectivity. Like Arduino, will have some limitations with the pins. Another microcontrollers like ESP32, they will have some sort of limitations in the pins that you could connect. Typically, you can go in a hierarchical fashion to connect as many devices as possible, right? So scalable infrastructure for all these IoT devices is again another research topic, right? You can play around with that. Okay, fine. So the next domain is semantic IoT, which is more similar to social IoT, but semantic IoT is more tailored to your own customized solutions. In semantic IoT, only major difference which you can see is, it uses semantics like all technologies, ontologies, and so on. And the other one is productization IoT, which deals with the customization of sensor applications. Like, for example, 3D printers, right? So you have something that you want to design. Maybe if it's in a group of people that you want to design something, everyone can group together and they can design something and they can make the production automatically with the help of the 3D printers and so on. So, for example, these days there are printers available even for even for constructing homes, right? So it becomes much faster and customizable, right? You can do it based on your taste. So we talked about what is IoT and the subdomains of IoT. I will quickly jump through the architecture. So what IoT has, right? So broadly speaking, it has only three parts: sensors, network devices, actuators. So sensors is very clear to you, which is going to sense, right? Actuator is the device which is going to do some actions. But in between, there is one part that is network devices. So these network devices is the place where cloud plays the major role, right? You could have edge, you could have fog, or you could have cloud. We will be discussing about them soon, right? So this is one of the typical example where air quality monitoring kind of thing could be done in IoT, right? So for example, from factory, you can, near to factory, you can have a lot of sensors to monitor the air, right? And this reaches the networked devices, right, which is here. Network devices could be edge, cloud, fog, and so on. And then you have the end actuators, like for example, based on the action communicated from the city, right, and that is given to the maybe to the factory unit or some units which can take some actions on or against the factories. So factories are producing a lot of chemicals, effluents, right, which has to be monitored. So this kind of architecture shows that, clearly shows that we can use sensor-enabled devices. Like, as I told, a normal architecture will have sensors, actuators, as well as network devices. So network devices will be responsible for doing analysis or to do some processing, basically, to understand which factory should be punished, which factory should not be punished, and so on. So that kind of actions should be done in the network devices, right? So sensors, yes, it has different shapes, it has different properties. You can sense typically like light or temperature and so on. So depending on that, it is classified into several sensors like light sensor, touch sensor, humidity sensor, temperature sensor, right, force sensor, water flow sensor, position sensor, speed sensor. So you can think so many applications based on these sensors. So sensors are going to sense some properties, and it is communicating to the network device. So in the network device, some sort of processing will happen. Based on the processing, we give it to the actuators, right? And the actuators should do some actions. So with respect to wearables, like consumer IoT, if you take consumer IoT, there are some sensors like accelerometer. For example, if you want to measure the movement, right? Accelerations, how fast, right? So for that, there are some sensors. There are some sensors to detect the angular, like direction, right? Angles, so that you can find. You can also find the global positioning based sensors, like for tracking purposes in wearables. Like you can have such sensors on the bag, and you walk, you keep tracked, right, where you go and to which location you go and so on. Then you also have heart rate sensors to help check the heart rates, pedometers, and so on. So sensors is one component. Then actuators. Actuator is going to perform some actions. It could be like even sending emails is a soft kind of actuator, right? Or sending alarms or creating alarms, or for example, controlling the flow of water, right? So all these are actuators. Typically, you can subdivide these actuators into hydraulic actuator, pneumatic actuator, electric actuator, thermal or magnetic actuator, mechanical actuator, and so on, depending on what kind of energy you produce or create here in the system, right? So we have seen sensors, actuators, and in between comes the network devices, right? So here comes the cloud part, right? So IoT is there, cloud is there, cloud-centric IoT. That's the topic where what we want to discuss. So when you talk about networked devices, you can have edge, fog, or cloud. So now we want to understand what is the major difference between edge, cloud, as well as edge, fog, as well as cloud. Cloud computing, as maybe I am just going to give a overall picture of what is cloud, right? It's typically an infrastructure as a service model, or platform as a service model, or software as a service model. So as a service, which means the computation or software is provided as a service in the form of HTTP protocol and using the typically through HTTP protocol, right? Through internet, you have to go access and you have to use whatever it can offer, right? So infrastructure means the computation is offered through HTTP protocol. So through the internet, you go and you get the computational power, right? For example, if you need 1 GB storage, then it is storage, right? That infrastructure, storage infrastructure is received, but it is through HTTP protocol, through your internet. If you need, say, computations, like you need i7 processor system, right? So then you have to go through the internet, you get i7 processor for computations. So then it is computation is given through internet, right? So it's a service, right? Infrastructure as a service. Platform as a service means you get the platform where you can work. So a platform typically can be like, for example, a .NET platform, or Ubuntu-based platform, or Fedora-based platform, right? Or if it is small OS, right? Or TinyML kind of, the platform will be given to you, right? So that is platform as a service. Software as a service means you get the entire software fully customized for your purpose as a software will be given to you as a service, right? So under that cloud domain, you have a lot of topics to discuss, like virtualization, whether it is full virtualization or para-virtualization, what kind of deployment models you target, right? Do you have hybrid private cloud or public cloud, or hybrid or community oriented? So all this comes there, and fundamentally cloud means it's the resources that you get through internet, okay, in the form of service. It is a pay-as-you-go model. That means whenever you need something, you can ask and you get it, but you have to pay for whatever you use. That's it. It is not for something like I need for 10 rupees. So a resource will be given continually. It is not like that. 10 rupees means you get for 10 rupees only some limited amount, right? So that is cloud. So it is expected that the cloud has provision for scalable environment. This means how much you ask, that much you should get, right? There are key players for cloud like Amazon, Google, Microsoft, and so on. So these people offer such kind of computations as well as storage, or something that you prefer, they give, but in a paid manner, right? So what is the difference now with cloud, fog, as well as edge? In fog, typically, like for example, I have a sensor. I need the sensor to send something, and I need to make some actions. Like for example, in air quality, I monitor the air, do some processing. I need to immediately complain that something is wrong or not, right? So if I have like hundreds or thousands of sensors, then how do you do you ask all these sensors to simply send a message to the cloud, which sometimes it will stay. These cloud servers can stay in the US or somewhere. So this particular message, sensed message, should travel through internet, and it has to go to the destination server for processing, right? So the time that it takes is very high, first of all. Second, it will simply load the network bandwidth, right? Killing some useful process in the later stage. So it is not always advisable to send all data to the cloud, right? Therefore, it is better to have some customized way such that we need not send all the data to the cloud, but a few of them should go to cloud, right? So therefore, they brought a concept like some computation can stay very nearer to the sensors. The computations that stay very nearer to the sensors are called edge, right? And so edge typically cannot have more computation capabilities, but it can do some processing there. But in fog, you can do a little bit more, but not as highest as in cloud, right? You can imagine like edge is like collecting some sensor values, and it is just seeing whether that sensor data should be forwarded or not, a kind of filtering mechanism. So edge can do like that. Whereas fog can add one small algorithm. It can run some small algorithm to do some sort of actions. So fog can do some sort of actions. So therefore, it can do some computations too, right? But cloud can do anything, right? It is highly scalable. But so can we simply ignore cloud? No. In IoT applications, it is always important that we should have cloud. So it's a platform for IoT analytics, but with the form of some intelligence here, right? So it can be stored in factory floor, near to vehicles, and so on. So these all are a form of networked devices. Why cloud should be freed from computation? Yes, it's because of latency. I have told that the data should go to different cloud servers. Typically, it can be in different locations, right? So that should be that could be avoided, right? So there is a question: fog and the edge can present at same place or same environment. Can present? You mean edge and the fog should stay very near? Not really. Like I think that is the question. So fog can stay typically in one. For example, if you are designing air quality monitoring application, edge could be the computational device. Like it could be like a Raspberry Pi, or it could be like a mobile device which will stay somewhere near to the sensors. Okay. But fog can stay in the city center as one small cluster unit. Okay, so as I have told, edge can typically filter the data. A small filter kind of things can be done. Like for example, you are monitoring NO2 or carbon dioxide. So if the carbon dioxide is exceeding certain level, then you send this data to send the data for some analysis. This can be done in edge. Got it? If it is a healthcare application, say the sensors need to measure heart rate. Okay, so your heart rate may be like 82 or something, but suddenly it is increasing to 130. Okay, then your edge device, typically mobiles are used as edge devices these days. So the mobile device can immediately notice this change. And if it is exceeding 130, it has to report to the next level. So therefore, some filtering is happening in the edge, right? Or if you need to do some algorithm, if you need to process some algorithms, it is better to have it in fog. If you need to process this with large historical data and do some robust analysis with a lot of visualization and so on, which could not be done in fog, right? So in that case, you should go for cloud. So fog is something like you can realize fog as a normal fog. Normally a fog is very nearer to you, right? You can see like white color staying very nearer to your place, right? But is it too high compared to cloud? No. Cloud is very far, but you can notice like clouds are everywhere, right? So it is something analogous to that. They have designed it here also, right? So fog can do better than edge, but not better than cloud. Okay, so I hope I understood. Yeah, so next one is, I talked about the edge. Typically, Raspberry Pi or similar kind of devices could act as edge devices. So all this comes under networked devices. So we are talking about IoT cloud environment. IoT cloud environment could have sensors, actuators, as well as edge devices, right? So there is another one direct message. Is fog also available as service or platform? Yes, it's available as service. I think it will be easily understandable when you see this diagram, not this diagram. I will talk about that diagram soon. So please wait. So applications, yes, there are so many applications. This diagram gives you a very good insight of how this edge fog as well as cloud is functioning. Okay, so you can see like cloud is centralized more or less in our picture, but it is a distributed computing environment. But it is like you get as much as resource as possible, right? If you ask 10,000 cores, you get 10,000 cores. But can you ask that in edge? You cannot ask. It will not be available. In your mobile will have only maybe 2 core, right, or 1 core. Got it? So that is the difference. Okay, let me proceed further. Yeah, talking about the services, people designed these services. Services can stay in even in edge, fog, as well as in cloud. Okay, services in the sense it can be some small computational part that is given, or which we can access through internet also, right? Earlier people designed this as a monolithic service, which means all the services are combined in one service. Later they designed it as microservices. So this means you will have small services put together, right? So the IoT cloud applications are designed in the form of services. Okay, and these services, instead of monolithic one, they designed it as microservices. So this means, like the service modules, which could be written in Node.js or Golang or even Python or C++ too. You can get smaller units of such services, which can collect the sensor data and do some processing, right? Microservices are better because someone wants to, in a IoT cloud application development environment, some developers will be comfortable with Golang, some developers will be comfortable with Node.js. So all these things can have different developer skill and so on. So you can typically develop your application much faster, and as well as the integration of this could be faster if you design it in a microservice form. Okay, So now, typically flexibility is much higher, modularity is higher, fine granularity as well as this one. Recently, people thought about serverless functions or serverless model of execution environment. So still we are talking about the IoT cloud application, where I told IoT cloud application consists of sensors, actuators, as well as network devices. And we are talking about network devices. In network devices, I told that you can have edge, fog, as well as cloud computational units. And these computational units will have services, right? The services could be designed in the form like monolithic service or microservices, and very advanced one which people normally these days do is serverless. What is serverless functions? It's a programmatic function written for a specific purpose, and it is like event based, right? So only if some events are triggered, there is a server to run the experiments. Right. In IoT based applications, typically if you see, the sensors are not always monitored. Sensors are not always monitoring the property. Let us imagine an example in a roadway, right? I need to monitor how many, say, ambulance travel. Okay. Typically in a day, if you imagine, I think 1 or 2 ambulance may cross, right? It is rare. Or let us take an example like healthcare application. I need to monitor the pressure of one young guy. Okay, and not a very chronic person, but a young guy. So typically this person, I think I have time, right? Another half an hour more. Can someone confirm this?
Yes, sir. Yes, sir.
Yeah, okay, thank you. So let us imagine that an healthcare application is required, and someone has you want to periodically check this, right? If it is checked, say weekly once, let us say weekly once, you are going to check healthcare. I mean heart rate or something of a particular person. If it is, if your IoT application is designed in a normal fashion, your application will run continually. It should run continually throughout the week, throughout the year. So in a cloud environment, when you want to host this application, if it is EC2, for example, if you take AWS, if it is EC2, you need to power on this EC2 instance throughout the year. So typically, what will be the cost, right? So per hour, you may have to, they charge like that, right, per hour. So per week, it will cost some amount, per month, it will cost some amount, and per year, it will be reasonably quite good amount, right? So, but if you see such kind of IoT application, which I have told you now, you are going to monitor weekly once a health status of a person. This means you may need just weekly once, one time, to do some computation to check that whether his heart rate is something like this, and this number should be updated in the database, maybe in cloud database. You want to update this, but your application is continually running, and therefore you have to power on the EC2 instance, and this EC2 instance is chargeable, right? It is, you are charging them. You have to pay for them. Rather, if you make it as serverless environment, which is like event trigger based. So once when the sensor has some data, okay, or once when the edge node is understanding that something need to be transported to the cloud, Then what you do, this event is triggered, and this event goes to the cloud. Since it is written in a serverless fashion, the functions can trigger the computation. So once when the sensor data goes to the cloud, the cloud will now search for the server, whether any EC2 instance is powered on. If it is not powered on, it will open or it will boot a new EC2. It will then transfer the data to the EC2, process them. Once if it is complete, it goes back to the normal state. So that's why server is not there. You are not charged for the entire weekend or month or entire year. It is only charged for the time when you use the EC2. Therefore, it is termed as serverless. Computation is happening, but it is currently there is no server. Once when the event is triggered and it comes for some processing in the cloud, now it is searching for the server and it is starting the server. So this is therefore called as serverless. So typically nowadays, executions in cloud are based on serverless, right? So substantial amount of money or cost you can reduce because of this in such IoT applications. IoT applications benefit a lot. Okay, so application developer does this. So the cost is extremely low. Okay, time to market is also low because it's somehow like a microservice environment. Scalability is very high. And even you don't bother about how many EC2 instance you want to trigger, right? It will be just left to the decision of the infrastructure provider. So you want to just focus on how to write the serverless functions. That's it. And then the rest, say someone was asking whether, how many sensors can I connect? You leave it to cloud, right? You just focus on serverless functions, you leave it to cloud. It will take the application as much as possible. If you want more scalability, the infrastructure itself will start doing that. This is the major advantage breakthrough in cloud for IoT applications. Enhanced scalability with very, very less cost, which is unimaginable with normal systems, right? So more time for user experience. Let us now see what all platforms are available for such environments. Yes, there are several platforms already available in this environment. That is AWS Lambda, which comes from Amazon. Then Google has Google Functions. Microsoft has Azure Functions. Kubernetes, they have this Kubeless. IBM has OpenWhisk, Iron Functions, FN platform, and so on. So already solutions are there. Okay, it will be something like this. Like for example, here I have shown an example where there is an image which has to propagate through the cloud in the serverless fashion. So it goes to the S3 bucket. S3 bucket will have the code, and this code will immediately is triggered basically based on the click, right? So when the image is uploaded here, the image, it's like a trigger. So the code and the trigger will go to the, because it's Lambda function, it goes to the real execution environment. Executions happen. For example, in this case, like detecting face and emotions. And then some peculiarity of the program is there, right? So that is happening. And once after that things are happening, it is going back and it is staying in the S3 bucket itself. Ultimately, if you see, you are not really using the computational resource much. If you don't use such serverless cloud environment, you will have to keep this application always on, which will cost you more, right? So that you can avoid here in this. So this is one of the architecture which we designed at IoT Cloud Research Lab of IIIT Kottayam. Sensors, actuators, then edge services with serverless, and fog services with some serverless, cloud services with some serverless. Okay, you can go through them also. Functions are triggered, based on the events, you can execute them also. There are certain performance concerns with this serverless functions, like security concerns are also there. Device hacking can happen, authentication issues can happen, right? Cross-site scripting can happen. Of course, all related to cloud security aspects could be there. Then memory size is another issue, because in serverless functions, you have only limited memory. There is also no sufficient caching of your application. So there is a high chance that what you did earlier is not cached. So you need to redo the entire process. Sometimes the server is not available. Of course, we know serverless means server is not available. So, but sometimes the EC2 instance is already not powered on. So this means you need to boot it again, right? So that can take more time sometimes. So when you boot, sometimes the required software packages of your application may not be available, right? You would have written your application in Node.js based on the trigger. Now it found some EC2 instance. It start to run, but there is no relevant packages there. So then the resources are not matching there. So all these are some of the issues that are there already in serverless environment, but people are working on that to solve this because it is more cost efficient. So as I told, mapping issue, non-availability issue, then cold as well as warm start problems are there. This is as I told, when it wants to search for the server is sometimes booted and it is available, but it is it could be utilized. It is free and it could be utilized, but already booted. So then when we call that as warm start, okay, because it is already started and it is ready with booting process, but not with the application. But cold start means you don't have even any of the EC2 available in your account, but now because of the sensors trigger, it came to the system, right? It wants to start. It's searching for the server. There is no server, not even booted up. So then it has to boot an EC2. It has to search for an EC2 instance, boot, and it has to start from there. So that will take more time. So that is called as cold start. Memory size is another issue that you get only limited memory size, right? So that is also another issue. Yeah, Sunil. So there is a question, let me read. We need to pay only for computation time in serverless, or extra charges maybe for serverless services. Yeah, this is you need to pay for the computation time, right? Naturally, but it depends. Like you want to say, sometimes you need high scalability, right? High scalability is required. Then you have to pay for that also. For example, you will have to say before you start, you will have to say I need 4 machines or 5 machines. But you will not start with 5 machines, but you have to specifically say that this is my bound, right? So then AWS can fully take care of the scaling part, right? Sometimes it needs auto scaling component also. It is chargeable. So in that sense, if you say it also includes computation plus the other services that it takes. okay, for the serverless. Okay, so, okay, proceeding further, impact of memory sizes, so it's just a trigger you can do, right? So, so it's a very limited amount of memory. So you should not, write the entire code and transport it to cloud, right? From the sensor, it will be just a small command coming to the cloud bucket, maybe saying that now you trigger. So when that trigger is there, immediately you should have some portion saying that the code should this particular code should go to the EC2 instance. So therefore, the size of the serverless functions that you write is very less. Okay, typically 128 MB to 3008 MB. If it is free, if it is paid, a little bit more, right? So that limitation is there. So to solve these performance issues with the serverless, there are some ways like tracing, sandboxing, modeling, as well as language inference approaches. And there are some tools already available, like Amazon X-Ray has from Amazon, then Google has some ways to do application insights, from for Windows, CloudWatch for Amazon again, then Prometheus typically for IBM, Thundra is a separate tool, AppDynamics, Wavefront from VMware, then Hexagon, and so on. So these tools are useful for doing the analysis, right? So here I have shown in the table that whether they are commercial ones or no, whether they are open source. Do they measure using logs, or do they use some kind of plugins? Is it a tracing approach? Do they use library or like a daemon that continually run? Whether the tool is service oriented, right? Then whether the tool can measure individual functions, or whether it can measure the task, or whether it can measure the entire application, right? So IoT application. So like that, that tool, that table explains the things, right? So there are some research directions in this perspective too, like you can write some extension to serverless functions for keeping them even more long-lived ones. You can have some visualization aspects which is not yet covered. Of course, PA tools, performance analysis tools are still vendor locked in based, because each proprietary people like Amazon, they have their own tool, and Google has their own tool. But it is better to have some neutral tools, right? If not, it is definitely vendor biased one, which you can avoid that, right? So that is there. Then integration issues, so you can. So yeah, these are some of the works which which is following this particular discussion. Yeah, I think we have another few more minutes. I would also like to make a small notification, like we have at IIIT Kottayam, we have few incubation centers, 2 incubation centers, MSME Incubation Center as well as Atal Incubation Center. Typically for MSME Incubation Center, you could apply for business ideas, right? You have some idea, you can apply, and there are n number of ideas with respect to IoT cloud, okay? And if your ideas are successful, you can get 15 lakhs per idea. So I recommend you to apply them. In Atal Incubation Center, we have support for startups. It focuses on startups relating to IoT cloud. So you can, if you have some ideas to develop as a company, and if you already have a company, you can approach us. There are several schemes where you can attract some funding, even sometimes to 1 crore also. There is also seed fund support with us, like each startup companies can get 50 lakhs, for example, right? So I recommend you all to apply or approach me to know a little bit more about that. There are possible ways where we can collaborate too, like joint product development, consultancy, MOUs, and so on. So with that, I would like to conclude the session by saying that we started with what is IoT, what are the trends in IoT, like what all things you can do with IoT, and I explained the different subdomains of IoT, like industrial IoT, consumer IoT, social IoT, semantic IoT, productization IoT, and then I discussed how an IoT architecture will look like. Okay, very basically, if you see, it is just a sensor, actuator, and the network devices. The major flavor comes in network devices part, right? And this network devices part is in very simple sense, it is cloud, but you can have edge, fog, cloud in this combination. And when we say edge, fog, cloud combinations, right, you typically use it as services. And these services could be written as monolithic, microservices, or in serverless model, right? When we and I told that it becomes much cost efficient if you use serverless functions. Of course, serverless functions, there are several platforms, including IBM OpenWhisk, Google Functions, Amazon's Lambda functions, and so on. So these are different platforms, and there are several performance issues too, and how it could be targeted. What are the different tools that are available for targeting that performance issues? And I also discussed some of the research aspects that are there in this field, right? With that, I would like to conclude. Of course, I welcome everyone to get in touch with us for this incubation centers. Thank you so much. Also, thank you to the organizers.
Thank you very much, Shahjalin sir, for a wonderful session.
Yeah.
See, if there are any questions, the participants can ask the resource person. He will be available. Sir. Yeah. Go. So participants can unmute themselves and ask the questions if there are any.
Yeah, presentation, PPTs and other resources will be shared to all the participants. Yeah.
So the PPTs will be sent collectively at the end.
So if no doubts.
Yeah, okay. Many questions were already asked, I think,
Yes.
during the session. Yeah.
Yes.
I think it was very interesting also. I would like to heartfully thank Dr. Victor Pal sir for giving me an opportunity to communicate with the interested people. Also, the moderator, Mr. Sebin Jos, for doing this wonderful job. And also AICT, of course. Thank you so much, sir. Also the participants. Thank you.
Thank you so much for your fruitful and very much knowledgeable session, sir. And thank you so much.
Thank you. Yeah.
So thank you, Shahjalin sir and Victor sir. So the attendance link is already posted in the chat box. All the participants are requested to mark your attendance using the Google form. And we are taking a lunch break from 1:30 to 2:30. And we will resume our next session at 2:30 sharp. Thank you all.